here. Gonna be for only a minute, but
Yeah.
I get that part.
And we get to go back
Then
to play Road Warrior.
Then I'll miss you again for a month, plus I don't know how long I'm gonna miss you. We may have to do remote. Y'all may have to go north. We may have to do, what's the one after the 13th? We may have to do that one from my backyard.
What, where are you going to be?
Depends on what happens on the 14th.
That's true.
We'll wait a few more minutes for more people to join.
Hey guys, jump on, come on.
Hey.
Tick-tock. If you're not 15 minutes early, you're late. Let's go.
We're going to talk some old school air conditioning here. You really want to be there for that.
Hey Jess, what's the 4 basic components of an air
Compressor, condenser, metering device, and evap.
See, look at her go.
I'm learning.
Now, did you get those in the right
Trainable.
order?
But there's an order?
There is an order.
Teach me, Mike. This is HVAC 101. What is it?
Comes out of the compressor, goes to the metering device, the condenser, then goes to the metering device, then goes to the evaporator, then back to the compressor.
Okay.
Which is why I give it to her in the direction that I wanted her to learn it.
Someone said, hello, everyone. This is David from Sacramento. Hello, David.
Well, hello,
Hey, David.
David.
How's the weather up there in Sacramento? Actually, that was Blue On's original home, was Sacramento.
Fun fact.
Yeah.
Fun fact.
McClellan Air Force Base.
Yes, it was.
All right, we got 22 people on. We'll go ahead and get started. So, hey, guys.
I think our direct is the lens cover on the.
No. Brian. Come
Oh, wait a
on.
minute. It's buckle up time.
Yeah!
Okay, welcome, everyone. Another Buckle Up with Mike and Brian. Mike is back.
Mike's back.
Woo! Let's get some
does
hearts
actually
in the
work.
chat for Mike.
It's actually Mike's front, but
I'm gonna turn
And
sideways, but it's
he's
one of those
rocking
cardboard
the sandals again. He's not barefoot this time, but he is wearing
should I do
those
half
sandals.
Mike, half Brian?
Yeah, Pete asked me to dress up.
Before we get started, our next live is May 13th for HVAC 101 Part 2. This one is HVAC 101 Part 1. So you guys can leave any questions you want to know in the chat about HVAC in general. They will cover it all.
Yeah, we're going to cover it all. We're going to try and get this. I think I explained last time that we've got this whole. We're supposed to be keeping all this stuff into a 30-minute segment. This one as well may run over a little bit.
Tell me it ain't so.
I know. If I can get you to quiet down.
Hey. That happens about 3
I got a
hours
couple.
night.
I got a couple of shout outs, and I'm sorry I don't remember the guys' names, but I talked to a few guys after our last one where I was in the condenser room, and I need to explain my glass. I don't need to explain the Diet Pepsi. That's self-explanatory. And no, I'm not sponsored by Pepsi, but somebody can help me out with that. But the blue glass does not have alcohol in it, guys, I promise. This is a long segment. We're in Studio B. It's a little warm, and I prefer ice cold soda. So that glass is literally full of ice. There is no Go Juice in it. I will do that when I get home. It's not that I don't have Go Juice. I just do it at home.
Cool.
So-
All right, we already have one question in the chat that we could start out with.
Okay,
Cool.
And then you can move into that.
Yeah, then we'll go into
This
a
is
little bit.
this is related to tech support. So they're asking if we run into a question about an existing system design, whether it's correct or can be improved, etc., can we call tech support? Thanks.
Yes, absolutely. We have quite a few people in our tech support realm, and we have two really good design people on the tech support side, so we can definitely hook you up and answer those questions, general questions. Mostly Mike and I field those really well. But if you want to get into the weeds on design and what the sizes should be down to an ounce behind, yes, definitely call tech support.
Cool.
And I had a tech support question come in early this morning to just further explain that kind of thought. The guy just wanted to know our opinion, or he was talking to me, so I guess my opinion on what type of torch to purchase, because he only had the money to buy one. So which one should he buy now and save up for the other one? He wanted a B-tank or oxyacetylene.
Oh, oxyacetylene.
So I told him that's exactly what I told him, was pony up to the oxyacetylene, because the oxyacetylene will let you do the B-tank stuff, but the B-tank stuff won't let you do all the stuff that an oxyacetylene will do.
So I actually had a tech call me this morning and say, can I get an address to send gifts? And I says, no, we don't do that. I said, well, I want to do something nice.
Pepsi.
I told him, I said, you know what? Go out and buy a new field piece probe.
Yeah,
Start building up the stuff. Build up the stuff.
Yeah.
Yep.
Absolutely.
You know, and I mean, one of the things that is totally serious, I mean, Brian and I screw around and go back and forth and everything. We very much enjoy talking to you guys. We enjoy helping. You know, I get so much pleasure when I'm talking to one of these young guys and I walk them through something and they goes, I get it. I understand it. That is, you know, that's what it's about, guys.
Yeah.
We want to help you. We want to educate you. Yeah, you do have to put up with my bad jokes, but you know, there's a price to everything.
And once we get to know you, and you can talk to the other guys that have gone through here several times, once we get to know you, as bad a time as Mikey and I give each other, we start sharing that with you guys. So it's all right. So HVAC 101. I'm not Mike, and he's here. We're going to cover things like terms, VOM, multimeter, common settings. We want to talk about gauges, digital, analog. We want to talk about checking low voltage troubleshooting and some high voltage troubleshooting. And the other thing we're going to get into is the basic refrigeration cycle. So we've got more listeners now, Jess. What are the 4 main components in an air conditioning system?
Compressor, condenser, metering device, and evap.
Sweet.
Look at her go.
Woo!
Now it's 4 weeks and we've only taught her for 2 days, so she's got it. So that's what we're talking about, Basics 101. Anything that you guys have, feel free. Mike and I are going to spitball this thing for probably another 15 minutes. So I'm going to toss it over to Mikey.
Okay.
And let him go through some of the common settings on a VOM.
Do I have to do that?
You don't have to.
Okay. I kind of a place I want to go is I've been getting a lot of call about low voltage shorts,
Yeah.
thermostat problems,
Yep.
not getting voltage out to condensing units and everything else. So I guess we can kind of work that right in there.
It'll work.
You don't always have to find the problem, but you have to eliminate all the other possibilities. So if you get the thermostat out of the equation and the wire between the air handler and the thermostat out of the equation, now you can kind of break that down and figure out if you've got a short in your wiring, if it's a component at the air handler, or if it's a thermostat.
Right.
You know, so it's really important. And going to that VOM, all right, please do me a huge favor. Make sure you have voltage present before you start trying to diagnose, because...
Or if you're going to stick your fingers in it, make sure you don't have power.
No. Have power there, because you will learn that lesson quickly. But no, seriously.
We got to give them the terms.
Yeah?
We said VOM. I said it, and then you repeated it.
Volt ohm meter.
Volt ohm meter.
Okay, now what does OL stand for? Because I've heard a couple different ones.
I don't have the book definition.
Some guys say
I say open line.
open line, or I say overload or over limit. Because if I've got on a setting for 1,000 ohms and I'm at 2,000 ohms, I'm beyond the limit or over the limit.
Okay.
So you're going to get that on there.
And then what is the difference when you're looking at a meter? What is the difference between continuity and ohms?
Continuity is measured in ohms.
But what is the difference? When should I read ohms and when should I read continuity?
Depends on what you're looking for. Because if you're looking at a sensor, for example, and I love the term 10,000 ohms at 77 degrees, because that is the one place where it all crosses.
Yes.
And that's the only time it's there.
That's the only time it's there. Yeah.
But the thing is, if you're looking, let's take one of the train defrost boards. If you're looking at that train defrost board, you know, if I've got a shorted sensor and I turn around and put my continuity on there and I get the beep, you know, yeah, it beeps. Is it good? I don't know.
No,
You know?
and that's the difference. That was the point that I'm making, is when you're checking continuity, think about it this way. If you're gonna ring out a wire, say you went to the air handler and you twisted all the thermostat wires back together, and then you go out to the condensing unit and you want to check to see if the wire's broken, use continuity. See if it tones. If you want to just put the meter down and see if you get tone, that's continuity. That means that the line is not broken. Has nothing to do with the resistance. So if you are reading ohms, like walk up to a furnace and you read continuity on your safety circuit and it toned. It's all great. Now take it and put it on ohms and read it again. If you're reading 50 ohms in the safety circuit of a furnace, one of the switches is bad.
Mm-hmm. Yep.
So it's going to throw the alarm on the board that you read continuity. Yes, at 50 ohms it's going to read continuity, but that circuit really should be like 1 ohm or less.
Well, let's take a step back. What really makes up a circuit? You have to have a power source, a potential difference, and you have to have conductors, and you have to have a load. Because you guys have heard the term short circuit. Well, take a 9-volt battery and stick a quarter across them and watch it arc. All right? It's a short circuit. There's no resistance. The current is just, and what part of it flows? It's the electrons. The electrons are going from negative to positive. So if you've got that short there, it's just boom. When you put a resistance like a coil or a light bulb or a heating element or any of these kind of things,
Pretty simple circuit.
yeah, there's resistance to the current flow. All right, so now you're controlling the current. And then we can get real technical and we can add a light switch, or we can put 2 light switches in there and turn it on and off from either one. So that's just a basic circuit. A short circuit means there's no resistance. You know, an open circuit means there's something open so you can't have current flow. All right, so it's some of the very, very basics. So
Yeah, I don't think 101 class 1 we get into how power flows through a wire.
it's power flow? I thought it was current that flowed.
That's why we're not going to get into
We do have a couple questions.
it. Okay, we'll take them.
First one, hold on, let me turn this camera on. Okay. What is the best tool to measure CFM from each supply/return?
Well, if you're doing it from the register, you want to use a vane anemometer as your best thing. You're going to you're not going to get a true number on the area because you've got the slats are kind of blocking a little bit, but you can get a relatively good idea.
That's for a portable vane anemometer
Right.
that you're doing average.
Right, but then if you're doing it in the duct,
you'll see a lot of guys go around when they're doing air balance and they've actually got a flow hood, which you can, it's already calculated back down to a 12 by 12. So you go from the 24 by 24 supply, regardless of what the duct is attached to it, and it'll read. But what you're looking at, something that's going to get you really close into the ballpark, is you take an average reading of your supply grills using the vane anemometer, write those numbers down, do your division, and that'll give you a pretty good average of what's coming out of that duct.
I mean, the other thing you can use, but it's not going to work real well on a register, is a hot wire anemometer, which is a probe that you insert into the duct. And
But again, when you're doing that, you should do the traversing.
right, you're doing traversing, but the hot wire is good for an insertion.
And that's another term, traversing. So you think about it as putting multiple holes and covering. So you take a square and you just drop a bunch of dots, And basically that's what you're doing. You take an air reading at every dot, you record that number, kind of like doing the average at the supply grill.
So you mean the air isn't all moving the same speed in that square duct?
No, it hugs the
No.
edge. It does a really good job of hugging the edge, and it does a whole bunch of weird stuff in a turn, which why they, yeah.
But anyway,
That's HVAC 202.
Yeah, but where Brian's going with that is you're not taking one reading, because you can have one reading real high, one reading real low. So you're taking a bunch of readings, you're averaging them together, and then you're coming up with a good number. So
Kind of like in the taking a supply temperature reading, you should never hold it outside the supply grill. You should always put the probe inside the supply grill,
Mhm.
because as it comes out of, and I'm going to use a really high-tech term, turbulence. As soon as it leaves that supply grill, it's mixing with the temperature in the space.
yeah, the ambient temperature.
So you get a mixture. So you want to get a real accurate reading. That thermometer, the tip of the thermometer needs to be in the grill, not laying next to it.
It's kind of nice if you can get it right in the plano.
Well, that would be good too.
Yeah.
But
Anyway,
you don't have attic loss at that point.
yeah, we don't do attics.
I don't do attics.
All right, next one. What will my analog gauges show if I have an airflow problem on a 410A residential system?
You're gonna have low pressures to begin with.
Your suction pressure would be low, but not necessarily. The question is you have airflow problems. So if you have too much air, then your delta T is going to be low. Your superheat and suction temperature are going to be high.
And if you have low airflow, your delta T is gonna be higher.
Yes, I had a gentleman call me the other day. He said his delta T was 43 degrees.
Cool.
Very. And I sing up on the suction line, and it's like, yeah.
What does that mean?
So what that mean? Which part? The delta
What
T.
does that
Delta
number
T
mean?
is the temperature difference between the return air and the supply air.
What's the significance of the 40 something number?
So in HVAC 101 terms, you're looking for 18 to 22 degrees across the evaporator coil, which is the difference between the return air and the supply air. So if you have, in this case, a 42 degree difference, or delta T, then the air traveling through that coil has slowed down to the point that it is gaining too much,
Removing too much heat.
removing too much heat out of the air. And what that does is makes the coil too cold. You're not boiling the refrigerant off as you need to, and that causes low suction pressure and extremely low superheat. And if you get the superheat low enough, you break a compressor.
Yeah, but it doesn't last long.
No, because as soon as you break the compressor, you no longer have a 42 degree delta.
Exactly.
Delta go to 0.
What are some tips that you guys have for newer techs going into their first summer season?
Bluon's got a really, really cool app.
We got a
You
great
push the
app.
tech support button, and
call
we'd love
Mike.
to talk to you.
Call
We
Mike.
really do.
Okay.
No,
Yeah, no, call
seriously.
us. Totally serious. Here's some good tips for a guy that's just getting into it. I talked to a gentleman who is relocating from the East Coast to the West Coast, and we had a serious, yeah. He's going from a decent climate. I mean, I realize it's humid, but he's going to like swelter.
Hell on
So you need to be prepared for the heat. Sunscreen, wear a friggin' hat. I don't care how goofy it is. Get a wide brim hat. Get yourself plenty of water. Do not run out of water. And yeah, I'm the guy that's going to push the safety aspect on. What does a new guy got to know? The new guy's got to know he needs water. He needs lots of water. He needs to be able to wrap a cold rag around his neck. Anything to keep you cool. Now, what do you need to know going in for the trade? You're going to be dealing with a lot of high head machines because they haven't done anything about washing the condensers for 2 years. So you're going to need to have garden hose. You're going to need to have a spray nozzle. You're going to have to remember not to use the needle point nozzles because you'll fold over the coils. The best way to wash a condenser coil is from the inside out on a draw through. Draws through the side, out through the top. You want to take the top off and wash it from the inside out because that's the way the air impacts in. So by doing it from the inside out, you're pushing the dirt out instead of pushing the dirt further in. You're going to have pressure problems. You're going to have systems that are out of refrigerant. You're going to find a lot of motors that are going to take a shit because
That's a technical term.
it is. That's an air conditioning 101 term.
Yes.
Motors are going to seize up because they're not used to working in that kind of heat. They haven't run. They were questionable last season. Now you're going to get into it. The other piece that you're going to look into is the first 2 weeks of heating or cooling season when it's 100 and some degrees outside, depending upon which part of the United States you're in. It could be 80 degrees and 80%. That's going to be your heat spell. That's when the machines are going to be put to a test. And just expect, as long as the sun is up, you are working.
I think one place I'd go with that is for the young guys, your basics are unbelievably important because if you've got that solid foundation of your basics, you can start building on those basics. Because I don't care how big the system is or how small the system is, all the basics are the same. Stuff just gets bigger, we start adding more controls to it, staging things on and off, but your basics are critical. So really take the time to learn your basics.
And some of the basics, know how to ohm out a motor. That's a condenser fan motor, indoor blower motor, and a compressor. Know that you got to have power off, wires disconnected.
Well, you disconnect the wires.
So that you don't have backfeed. I think that's next week's class. Disconnect so that you're not having backfeed. If all the wires are hooked up and something is wrong in the compressor and you're reading the condenser fan motor, it's the same contactor. So you're thinking you're reading a bad condenser fan motor when in fact you got something going on with the compressor, or vice versa. So always disconnect the motor wires from whatever the source is.
I like to say divide and conquer.
Divide and conquer. Yeah.
Because if you separate the
Divide
things
and
out,
own.
yeah, exactly. If you divide the things out, you can now pin down where the problem is. You've got just a bunch of simple circuits to make up the electrical within a unit. So you're just looking at each one of those and looking for problems. One thing that, and this may be 202, but anyway, one of the things that I've run into is guys like to use ground as a reference point. So they turn around and they go to ground, they read one side of the transformer, they got 120, they read the other side of the transformer, and they go, okay, I got 120. So I got 120 on both sides, so that's 240. Not necessarily, because you can be reading the one side all the way through the transformer, and so you're reading the same leg to ground, but you don't have 240 across the transformer. Because if you think about the transformer, it's not a 120 plus 120 transformer, it's a 240 transformer. So you got to have both sides of it there. So again, going back to basics, always check your voltage to make sure. I do some crazy things with electrical and stuff like that, but one of the things I always do is I know if the equipment's hot, I know what's going on with it, and if I'm getting in there, I know there's power, or if I'm going to do other things, I make sure the power's off. And so a good meter that you can trust, and another thing you might want to do once in a while is take your meter and just put it into a wall outlet. Make sure that, oh, okay, it works. Because you go out on a job site and your meter doesn't work, you plug it in, no, there's no power there, you stick your hand in, and it's like, oops.
And here's another, not only to check and see if your meter works, but here's a good way to check and see if your leads are any good. And that's when you can do your continuity test and your ohms test. Put it in continuity, put them together, see if it tones, you're 50% there. Now put it on ohms and read your ohms. So you should be at 0.01 or 0.02 on your meter leads.
Depends on your motor, your meter and your leads.
Depends on your meter and your leads.
It's going to be extremely low value.
Typically it's going to be 0.01 or 0.02. I've got some long leads that get into 3 and 4, but I don't think these kids are going to be. At any rate,
He digresses.
101,
He
yeah,
digresses.
101, you're probably not going to have 10-foot leads.
No.
We have one more.
And the other thing, okay, go ahead with yours.
A little bit of a different topic, but what causes the compressor to overheat?
Well, I want that one. I like that one.
You like that one?
I like that
That's a
one.
mic
There's
question.
15 different causes of why a compressor can overheat.
Number one, if you're having an electrical issue, like you're having bad capacitors and things, you're going to cause your windings to run a lot hotter. Another thing is if you have improper voltage or voltage imbalance, you will also cause heating going on. If you've got bad contactors, you're going to increase, and screw with the voltage going in and overheat. Now going over to the mechanical side, if you're low on gas and you're running a really, really high superheat, because what's the refrigerant doing? The refrigerant's cooling that motor. And I think Copeland says anything above 35 degrees can be fatal to the compressor. So you've got to get the refrigerant flowing through there. I've had guys call me and they go, I got a 75 degree superheat.
I believe that's 60 degrees. Suction's over 60 degrees.
Superheat.
Oh, dead. Superheat
Superheat.
over 35.
Yeah.
Compressor's dead.
Yeah. But the thing is, when
I thought you were talking about temperature.
No.
Not superheat. All right.
Thought you had me there, huh?
No. Put my damn seatbelt on.
So, one of the things, and I'll just hit this real quick. People ask the question, why do compressors fail? I don't know. And that's so untrue because compressors fail for basically two reasons, mechanical or electrical.
Or electrical. Yeah.
And if you have too little superheat, you could be flooding liquid back to the compressor and you can't compress a liquid. And so depending upon how much liquid's there, something's gonna give.
Yep.
Bigger compressors, it's usually rods coming out the side of the crankcase. Smaller compressors, they lock up and they break.
Doable.
Yep. Real high superheat, you're overheating the windings, and as a result, the lacquer can break down and everything. You go to ground and you're like, oh, I've got an electrical problem. No, you didn't have an electrical problem. You had a mechanical problem that caused
That
it to
turned
run
into an
hot.
electrical
Yep.
problem.
So there's a lot of things there, and as we get more into this, you'll understand the system and how it works, because it's a system. Everything is doing something. The evaporator, we're boiling off the refrigerant, we're transferring heat, we're bringing that heat back to the compressor, we're compressing it down, and we're condensing it and getting rid of it. So everything works together.
Yep.
It's just like on some of the
Yeah.
heating calls we got.
It still all works
Yeah,
together.
but I mean, where the guy says, I've got like 100-degree differential across the heat exchanger. Well,
It depends if it's an old Holly, that's not good.
Mhm.
He needs to crank up the gas. But on the new pieces of
Yeah.
equipment, that's a little hot.
but I mean, it's where I'm going with that is that you've got a tool that if the machine says, hey, your heat rise across the heat exchanger should be 25 on low heat and 55 on high heat, and you turn around and you go in there and you've got a really, really high number, just using a thermometer, I can turn around and make an assumption that I've got an airflow problem.
Right.
Just like if I've got a really, really low number, chances are I've got an airflow problem.
Right.
So it kind of gives you just another tool to check to see what's going on, because there's actually, in installation manuals, there's really a lot of information.
You can
Yep.
if the install manuals are still there.
Mm-hmm.
But I want to touch on one more thing for the new kids. The guy that asked the question about just getting in. This is
Mhm.
his first summer.
Yep.
It didn't take me long to figure this out in a couple of hits in the back of the head. But when you're just starting out, 9 times out of 10 you're going to be dealing with residential calls, and when you're talking to that client, the first thing you want to find out is where the thermostat is. So you walk up to the thermostat and you make sure that it's set for cooling. Turn the fan to on. It's going to be an auto, so you make sure it's set for cooling. You make sure that the fan is turned on, and then you make sure that the temperature is set minimum of 5 degrees below what it is in the space when you get there. If you do the same thing every time, it becomes a routine. Now you find out whether it's a split system or a package unit. When you get to the machine, you turned the thermostat on. Now you're going to start checking for your 24 volts. The machine's not running, it's not doing anything. Now you check your 24 volts. If you have 24 volts at the machine and you're not getting it back from the thermostat, you know you turned it on. You don't have to crawl back down out of the attic, crawl down back off the roof. You don't have to do all that stuff. Mikey likes his jumpers. They've got their place in life. And at that point, because you don't have to go back down to the thermostat, now you can take out your jumpers, disconnect the thermostat wires, and now you can jump and see if your problem is between the unit and the thermostat.
Because what really is a thermostat? A thermostat is simply a temperature controlled switch.
Yes.
That's all it is.
So
You know, and so the thing is,
people make them fancy though, because you can.
what was that one manual I got? 368 pages for a friggin' programmable stat? Dude, I'm gonna send you the manual because I'm not going through all 368 pages. Sorry!
We love you, but
But no, seriously, break some of this stuff down into its, simple components. I mean, if you got a compressor that's not starting, don't go look at the air handler. The indoor fan, that's not your problem. So zero in on the area you're having the problem and start looking at things that can affect it. One of the things that we ran into a lot with defrost control boards and everything, they can't get something to work. Defrost control boards, you've got a lot of low pressure switches tie into them, high pressure switches tie into them. You got a coil sensor temperature, an outdoor air temperature sensor. You could have a defrost thermostat of some type. So you got 5 things tying into that board.
yeah.
That could be the problem, and it's not the board. So, I mean, I got no problem condemning boards, but I want to make sure that I've gone through and done my due diligence to eliminate everything else that's a possibility. And once I've done that, if all else fails, okay, it's probably the board.
Yeah, because I had one today. All signs pointed back to the board.
Mm-hmm.
They accept. And
Good.
once we got to the accept,
Yeah.
then it's like, okay, now you got to start at the board. And yes, he had 24 volts leaving the board. He did not have 24 volts coming back. And it's like, you got to find it. It's in that machine someplace. You got 5 safeties in that machine, and you got to find them all. He had to physically go and touch each switch and ohm out each wire and
Well, this kind of leads into something really cool because you've got things like the high pressure switch, which is simply a digital switch. It's either on or it's off. Your low pressure switch, same thing.
on off.
Defrost thermostat, on off, all right? But your temperature sensors are now resistive. And so without knowing exactly what the numbers are, if you read that sensor and you have either 0 ohms or a dead short, or you have an open or the OL, chances are that's bad.
Yeah.
Yeah, you're gonna want a number somewhere in the middle.
So what Mike just said is if you walk up to a condensing unit and the code on the board says that you have a bad outdoor sensor, unplugging it and taking a jumper wire out of your pocket and going from S1 to S2 does not eliminate the alarm.
And it might let smoke out of the board.
So, 2 failures on a sensor. A sensor means that you're going to read ohms. You're not going to read continuity. So,
And what happens with those sensors, most of them are what they call NTC, negative temperature coefficient. So as the temperature goes
I came
down.
up with a different one for that.
Did you?
Yeah, that I can't say on.
Oh, okay. But as your temperature goes up, the resistance goes down. It's just opposite.
We have another in the chat. Any tips to verify failed or properly working pressure/temperature sensors?
Well, there's a really kind of cool test, and it's really kind of amazing. If you want to verify temperature sensors, you can take ice and water, and that's going to be 32 degrees, and you can use that as a reference point for calibration and everything else. On pressure switches and things like that, if you got a good set of gauges, you can kind of manipulate the pressures a little bit and see if it's actually making and breaking where you expect it to make and break.
Yeah. And believe it or not, Pressure switches just fail.
You know, another thing that I just learned, parts can come out of a brand new box and be bad.
And they're still bad.
And they're still bad.
And they're still bad.
So,
and then I noticed we had a lot of questions, and I'm sorry I'm going way, way backwards, on the heat pumps with the coil temperature sensors. They put them in a well, and they get constant failures on coil temperature sensors. The coil ices up, and it crushes the sensors because they're cups. So I was telling a whole lot of guys, take it out of the well, zip tie it to where the well's at. But at any rate, I digressed. My bad.
you did.
I did. I went way back into December.
All right. Will an ECM blower compensate total static pressure and CFM if the return air or supply air is undersized?
No.
It's only going to go so far.
In a nutshell, the answer is no.
Yeah. ECM motors are basically a torque control device, and they can overcome some things, but
It doesn't. If it had that type of control configuration, it could.
If you're a true variable speed.
Because the ECM motor, the way the ECM motors are, but it's the technology that feeds it. So they're utilizing ECM motors to pick speeds. So, for example, our test chamber, we have some big ECM motors, but we're looking at total static pressure, and they ramp up and down
To maintain a static pressure.
based on static pressure. And that's not what's happening on most of these ECM motors. If you got a condensing unit with an ECM motor and it's a 2-stage compressor, then they have a fixed speed for first stage and they have a fixed speed for second stage.
Yeah.
So it really doesn't vary depending upon the pressure or the temperature. It's fixed speed. And the same with the indoor. The indoor has a heating speed on the fan, it has a cooling speed on the fan, and then if they just want to circulate air, that's a third speed on the fan, but they are fixed RPMs.
Some of them got a little bit of torque.
Oh, the ECM motors have got torque.
Yeah, but the thing is that you can't compensate for poor ductwork by just keeping it going to a bigger and bigger motor and pushing harder. You got to fix the problem.
So yeah, I think he understood he knows he's got duct issues. Will that compensate for it?
No.
The true answer is no.
Let's go to the next one. Would you recommend a hard start on new installs?
Would I recommend it? There was a manufacturer out there that sent one in a box with every unit.
That gives you the warm and fuzzies.
And their statement was, if it needs it, it's going to need it at startup. And if it doesn't need it, put the box in your van. It's a opinion. So start kits, are they necessary? No. Do they save a little bit life on the compressor? Probably.
Yeah, and they can help compensate a little bit for low voltage and that, but it's
Just because they are a start component. It's not going to prevent you from having to change a contactor that has more than 1 volt drop across the contacts. So, but it'll help the compressor get started a little bit faster. It's just that boost of power start to get it off top dead center.
Yep. You got top dead center in compressor?
I don't know how else to explain to get the rotor to spin.
I was kind of
So I
looking
always
for
said
the scroll.
top dead center.
I was looking for top dead center on that scroll.
Scroll you, Mike.
Okay, we'll start to wrap it up here a bit. We have a few more questions we'll get through, but if you have any last minute HVAC 101 questions, be sure to leave them in the chat.
So guys ask a lot on the gauges, digital or analog. And it depends on what you're doing and how finite you want to get. The newer equipment is getting a little bit more finite to where you're going to have to start switching over to digital. If you're doing start, test, and balance, a lot of the agencies that are accepting the paperwork, they will not accept analog information. It has to be, they want to see the decimal point. So it's 62.8 pound suction on R22. They'll want to see that. They'll want to see the temperatures. They'll want to see the temperatures in the decimal points. So the whole world is switching over to digital. Does analog work? Yeah. Analog still works, except when you're getting into the new blends. The manufacturers, there's just not enough room on an analog gauge to put all the ribbons going around.
Well, then what are you going to do on the dual column?
Well, you know, you have the blue side and the red side, Mike.
Yeah, but what if you got the blue side on a liquid? Then you're going to run into some problems.
Well, yeah, especially if they get a retard.
I don't know. One of the things, coming from the big world of chillers and a lot of that kind of stuff, and I would talk to guys and I'm like, okay, so what superheat do you use on a passive metering device, a cap tube? Well, maybe 12 degrees. No, because the cap tube is not changing. The only way the flow on a cap tube changes is if your liquid pressure goes higher and your suction pressure goes lower. The differential is what affects the flow. So the thing is that with a lot of the new stuff like Measure Quick and the field piece and everything, they give you the target superheats, which can make your life a lot easier if you're doing a lot of cap tube work in that, because they're looking at the return air enthalpy, they're looking at the outdoor dry bulb, they're looking at supply air and everything, and they're continually changing the target superheat based upon the actual conditions. And you're not going back and forth and saying, okay, now it's 77 degrees outside and the wet bulb just dropped another degree. Oh, I got to recalculate.
And
So-
get yourself some good digital thermometers.
Yeah.
You've got the ones that are strictly dry bulb, and the cost of the dry bulb, wet bulb thermometers, otherwise known as a sling psychrometer. I still have the
one on
old.
my desk.
I have got a couple of slings in my museum at home. But they make them very reasonably priced, because if you're looking at the charging charts on a lot of these machines, and it's going to ask you for indoor wet bulb return air temperature and outdoor air ambient temperature. Ambient temperature is the temperature in the space that you're standing, whether it's indoors or outdoor. We refer to the ambient condition of inside a house as the return air.
And
And the ambient condition outside in the summertime we refer to as hot.
I'm going over to hot next week.
Hotter.
Hotter. One of the things you can do too, with and I really have grown to really like the field piece probes, but if you got to get stuff over time, you can buy the hygrometer like Brian's talking about, and you can get this one now, and you can still use just a dial thermometer outside for the dry bulb, and then
Well, you can take but you can take, if you had a choice of buying one thermometer that gave me both readings, or man, I'd really like to have just two dries. Okay, then get two dry thermometers and go to the 99-cent store and get a shoestring. Oh yeah, shoestrings work on dry bulb thermometers. You cut off a section, you feed it over the dry bulb thermometer, wet that thermometer like you would with a sling. Yeah, I get it. And you have a wet bulb thermometer. These are tricks that you pick up over time when you're dead ass broke.
yeah, but I mean, really in the days when you and I were younger.
Yesterday.
Yeah, you lie like a rug. You know, they didn't have a lot of good options.
Right.
You know, I mean, you were stuck with a sling psychrometer and stuff like that and doing the math. You know, it's what you had. And there was no great degree of accuracy with this stuff. But the tools that are available today are just,
Kind of like the Blue One's mobile app.
hey, that's pretty cool.
That's a pretty cool tool.
That's a pretty cool tool. Yep.
Nice.
And there's a button, you push tech support and get Brian.
That's right. And if you don't like Brian, you can skim through and look at the other 15 guys' faces and then hit the red button and still get Brian.
Still get Brian.
But it's nice that we got our faces on there. Updates. Make sure that you update the app either, often, because it's changing often. Automatic updates are the greatest. When you do your updates, make sure that you allow us to do push notices so that you know we got updates. Pardon me. The forum is coming, right? Freaking
This
love
summer.
the forum. Summer of 2021. Oh yeah, that's only a couple of months away. Oh man, I'm so excited that that's going to get here.
Well, that's
and
amazing.
again, and this is for right now. It's going to change. When the forum comes out, we're constantly changing things up to make it easier and better for you guys. But right now, remember, you still got the 3 options on the tech support when you call: manuals, under 20 ton, and over 20 ton. So if you're looking for a manual, click manual. If you have technical support questions, as well as looking for a manual, then click option 2 for 20 ton or 3 for over 20 ton. We try and staff the manuals. It's not always a seasoned mechanic that's on manuals. So to save your time of, you have tech questions, they have to transfer you to one of the other guys. Anyway, please, just call us. What the hell?
Just call us.
And then May 13th is HVAC 101 Part 2 or Part 2.
So think of those questions.
Tell your friends, comments, like, subscribe, hit the bell, Instagram, YouTube. Where else are we at, Jess?
Facebook,
Facebook,
Twitter,
Blue on
LinkedIn,
Brian,
YouTube,
needs the love.
Instagram. Yeah, we made Brian an Instagram account called Blue on Brian if you want to go give him a follow.
And he's crying, man. He's only got like 3 people. It's sad.
No, you have 75 now. 75 followers.
I was trying to up the ante.
And we're almost at 10K on Blue on Community, so go and tell your friends to follow us because we really, really want to hit 10K ASAP. So help us out, please.
Please, please.
All right.
We love you guys.
Peace, y'all.
Have a
Stay
good one.
safe. Stay safe out there. We'll see you next time.
Be good.